Okay, a little bit unrehearsed, but let's give it a go to see anyway. So, over on the left-hand screen here, two windows. On the left, this is my Modbus slave application. So this serves two purposes. The first is it simulates the inverter. That means you can send Modbus RTU requests to it over a serial link, and it will respond with register data. And it's based around a snapshot that I took a couple of years ago from our actual inverter. But it also simulates the data logger behavior as well. And that basically every 5 minutes goes off and collects the data from the inverter that then gets pushed off to the cloud. So it simulates all that behavior. In the window next to it, you have my Modbus Broadcast app, and this is the software that I put together that is designed to talk to the inverter and allow me to query data that I can then use locally. Those two are connected together via a simple null modem cable using RS232. In reality, that'd be sat on the RS485 bus with the data log and the inverter. So if we fire these two things up, so the first thing you'll see when I fire up the Modbus Broadcast app is it sits there to sync with the logger, and basically what it's looking for is that burst of traffic that happens every 5 minutes, so it can synchronize and then start using the free space after that. So if we now fire up the simulator, you can see here the Modbus app has seen a bunch of traffic going on, and this is all the traffic that the logger's collecting from our local inverter that it can just happily ignore. That normally takes about a second or so to get going. After that, the data logger then starts polling for additional inverters that might be on the bus. So there's potential for 10 devices, what they call slaves. Normally most people have only got the one. This is now polling slaves 2 to 10 with a bunch of register queries. And what the Modbus Broadcast app is doing is answering all those queries with just an illegal address exception, which you can see being handled over here on this window. And the reason it does that is the data logger has got a timeout of 3 seconds for every register access, and that means if it left to its own devices, that takes about 3 or 4 minutes, which means you get very little spare time before it starts doing its polling. Once it's got to the end of that cycle, you've now got about 4 minutes free. You can actually see it's taken 45 seconds here to do that transaction. You've got about 4 minutes free bus time, and normally the behaviour of the Modbus Solace app would then be to every about 15 seconds read about half a dozen registers to query sort of current status information, which you can see here. It puts that, packages it up into a JSON structure, which it then pushes out over UDP. And this is the stuff that I then use for my local displays. You see, it's basically got current consumption, usage, whatever it is, and it does that normally for those 4 minutes, and then it goes back to the syncing with the logger. And the recent change I've added is to allow this application to also operate as a Modbus TCP server, and that means it can accept arbitrary Modbus requests, which it forwards on to the inverter and then relays back to the client. And to demonstrate this, I've been using the Solace Modbus integration into Home Assistant, which I've got over here on this right-hand display. And this is a split window, so you can see the integration over here on the right-hand panel, and then the sensors, which are currently all unavailable in the left-hand panel because I've got the thing turned off. So if we enable this, what you'll then see it start to do is it then starts issuing register requests over TCP, which are then picked up by the Solace app, the Modbus Broadcast app over here. So I've just enabled it. Let's bring up the control panel over here. Activity. So we can see down here on the Modbus Solid app, we've got some register transactions that have gone in. Now, what you can see there, what happens is I don't action them immediately, and you can probably just see that these sensors over here have just snapped into life. 2.2 amps over there where they were previously 0. It happens pretty quickly, but normally what happens, like I say, is I don't action them immediately. They just get deferred, and then I action them on the next available 15-second cycle. And you can see there's a bunch of things going on there. So if I just scroll back up here, you can see here we've got the add new transactions going on. This is what the Solace integration app has asked for. Next time I come around to poll them, I execute them all. Now the Solace integration app in Home Assistant has got like 3 polling cycles. It's got a 10-second fast poll, 30-second normal poll, and a 60-second slow poll. I hold on to the register data for about 60 seconds, after which I stale it off, and this will have to put in new requests. It's putting in new requests all the time, and I'm just giving it the previous set of data it's had. And you can see that basically within a few, in fact the sensors count very quickly, but within like 30 or 40 seconds, all the information on the controls and everything should be available down here. And we can actually now start playing around with toggling the AC coupling. Actually, I spoke too soon. It's not quite ready yet. What it can take a minute or so to bring everything up, because, like I say, those requests are not actioned immediately as they would be if you were connected directly to the inverter. They've got to be wait to be scheduled in by the application. Are we available yet? Oh, there we go. And you can see what's happened there. Now I've turned that on. We've now got a write registered transaction that's been queued into the system. Got some more new reads that the app integration's asked for. Next cycle should come round, and we should see in amongst all of those, we've got, let's scroll up a little bit, here we go, executing, writing register is about here, there we go, so that's where it's been actioned. And then the next time the integration app asks for the status, it will do another read, and that will be scheduled in due course. So, generally speaking, although it's not really designed to work with this particular app, this particular integration that does a lot of transactions, it is quite responsive. The idea behind this is more for doing small, the odd discrete scripted type operation, say to scheduling a grid charging slot or whatever, but it does work quite well with this. And what you can see now, just as before I close off, is you see we've reached the end of our 5-minute cycle. The Modbus integration app has gone back to its sync state. The simulator app says there's about 21 seconds left before the next poll, and here we go again. Here it's gone off. So this is the data logger now doing its thing, retrieving the local information. So I say, for the most part, it's going to be quite responsive, except during that 40 to 50 second window where the data logger is busy, at which point you would definitely see a lag because nothing else can be scheduled on the bus. That's just about it. Blimey, only took 2 goes.